Hello and welcome to today's video. All right, so we have our third question that we are looking at in our series of solving 100 Harvard style equation question. All right, so we have the question: integrate cos 2x over cos x dx. And that is the question we want to solve today. All right, so we'll be making use of our knowledge of trigonometry and seeing how we can make simple manipulations to solve this interesting question. All right, so we'll go like this. So we have cos 2x at the top. Now, if you recall from our knowledge of trigonometry, we know that if we do cos A plus B, right, this can be cos A cos B minus sine A sine B. And that automatically means if I have cos 2x, right, it means I can say that my cos 2x is actually cos x plus x. So, I mean, if we expand this now, it means this will be cos x minus sine x sine x. And cos x is the same thing as saying cos square x minus sine squared x. Now, having understood that, we can also go ahead to establish the fact that we know that 1 over cos x is also equals to sec x. So 1 over cos x is actually also equals to sec x. So it means I can now say that the integral of cos 2x over cos x dx now can be the integral of 1 over cos x multiplied by cos 2x dx. And it means I can say now that this means 1 over cos x is sec x in bracket. Then this is cos 2x that we have at the top here. And that will be cos squared x minus sine squared x dx. And this is interesting. So what other manipulation can we do? So if we recall, there's a simple trigonometric identity relationship that we should recall. We know that cos squared x plus sine squared x will actually give us 1. And that this actually means that I can say that this implies that cos square x can be equals to 1 minus sine square x. All right, so I'm going to substitute that back into what I have here, and I'm going to have integral of sec x into 1 minus sine square x minus sine square x dx. And if we go further now to simplify this, this gives us sec x into 1 minus 2 sine square x dx. Minus sine squared minus sine square x will give us a minus 2 sine squared x. So I can expand this, apply the expansion of this. So this becomes an integral of something like this sec x minus 2, right, sine squared x sec x then dx. So since integration is a linear function, right? Is a linear function, so I can apply the idea of linearity and say that this will give me integral of sec x dx minus integral of 2 sine squared x sec x dx, right? So right from here, I can now say, okay, this is integral of sec x dx. So I bring out 2, since 2 is a constant, we have 2 integral of sine squared x, right? Then sec x dx. Right now, this is a very, very, very interesting. So we can do something like this. I'm just going to make a new slide. So I'm going to make a new slide. And then right from here, from what we have here, I will go to say that I want to change my sine squared, right? I want to change this again, such that we will now have this equal to sec x dx minus integral of 1 minus cos squared x, right? Then sec x dx. So we know that from here. We know that from here, from this relationship here. So if I decide to make sine squared the relationship, the subject, that will be sine squared x equals to 1 minus cos squared x, right? So, and that is what I actually did here. So this gives us integral of sec x dx, right? Minus, I'm just going to do this bracket here so that this becomes sec x, right? Minus, dx, minus integral of sec x cos squared x dx. So, right, don't forget that we have a 2. Don't forget that we have a 2 here. So I'm just going to go back and I put my 2 and my 2 here. So this will be integral of sec x dx minus, I use this 2 now, this negative 2 to expand this bracket. So this becomes 2 integral of sec x dx plus minus times the minus here, that gives us a plus 2 integral of sec x, right, cos square x dx. So of course, integral of this minus this, you see that they are the same term, only that this is having a 2. So this can be minus integral of sec x dx, right, plus 2. Now we know that sec x is actually 1 over cos x, so this will be 1 over cos x dot cos squared x dx. Now, when I integrate sec x, I'm going to get minus, the minus at the front here. So this is ln. When I integrate sec x, I'm going to get ln tan x plus sec x, right, plus 2. One of this cos, we cancel one of this integral of cos x dx. And of course, when I integrate cos x, what do I get? I get sine x. So this will be minus ln absolute value tan x plus sec x plus 2 sine x, then plus my integral constant c. So I can easily just rewrite this as 2 sine x minus ln of tan x plus sec x, then plus c. And that is the solution to our integral. I hope you learned something interesting in this video, that it's not all integration that you have to tackle using substitution or using integration by part or integration by partial fractions. Sometimes it's just little trigonometric manipulations, little algebraic manipulations, and we're able to see through our integral question. I hope to see you on the next series where we'll be tackling another interesting question. See you on the next one. Thank you.